So question 1, which of these statements is incorrect? Incorrect about uniform circular motion. Right, so here we have to find the answer that is a wrong answer. So the one is the speed is constant, correct? The velocity is changing with time, correct? The object is speeding up or slowing down, wrong. The directions of the velocity is changing with time, wrong. So the answer is C. So take an example of an object that goes in a circle. So it has mass m and the speed is v, tangential to the curve, and the centripetal acceleration is towards the center. So this is the circular motion. So the concept here is that the speed v, which is only has magnitude, must be constant. Right, then the second one is that since it moves in circle, so the circle shape is not a straight line. So that must means that the direction is changing. So since the directions of v keep changing, therefore we say that velocity change. The velocity change as well. So that's why answer B is correct, A is correct, and D is correct. So the object cannot speeding up or slowing down because it have a constant centripetal acceleration. A constant centripetal acceleration. So AC is not increase, AC is not decrease. So the answer C is wrong. The next question 2. So you are given the blades of a table. So this is picture of blade. Okay, there are 4 blades. It makes 25 revolutions in 1 minute. So this is quantity omega. So omega says 25 revolution in 1 minute, means per minute. Right, so what is the angular velocity of the blade? So we are looking for omega. It means that how fast is the rotations of the fan. So omega. So then we need to convert omega into its SI unit. So we must know that the SI unit for omega is in radian per second. So means revolution must be converted to radian. So put down the revolution and up is radian. So then the revolution can be cancelled out and the minute change to seconds. So next we have to put minute up and the second down. So then the minute can be cancelled out. So this is how you do the conversion. So 1 revolution equal with 1 cycle, which is 2 pi radian, and 1 minute has 60 seconds. So then just press in the calculator, 25 times 2 pi divided by 60. So the answer is 2.62. Unit is in SI, radian per second. So the answer is B. So next, question 3. You are given 3 hands on a clock are called hour hand, minute hands, and the second hand. What is the angular velocity of the second hand? So we are looking for omega. Okay, so omega, the concept is that pi by period. So what is the period for second hand? Okay, so we have a clock. 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So the second hand is the one that has the longest length. So this is the second hand. So it makes 1 cycle for 60 seconds. So that's how second hand moves. So the period of rotations for the second hand is 60 seconds. All right, so this is for second hand. So we are dividing to pi by 60. So the answer is 0.105 unit radian per second. All right. So this is answer. Question 3 is A. So next, question number 4. A mass move in a horizontal circle with a constant speed of v1. So we might be able to draw a picture. So this is a mass m, for example. So it moves in a circle. So it has speed v, labeled down as v1. When the same mass moves in the same circular path, so means that what quantity that we remain constant is the mass m. So since it moves in a same circular path, means that the radius is also the same. So this is the radius from the center to the circumference, that is r. So the radius is the same because there's the same circle. But only quantity that change is the v. Okay, so the v. All right, so here we have to find the centripetal force. All right, so it says here the centripetal force is half of the first. When we change, when the same mass with speed v2, the new centripetal force is half of that of the first. Okay, what it means by that is we can take out the formula for centripetal force, which is mv squared divided by r. So for the first circle, for the first mass m, it has v1. Okay, and then since the mass and the radius is constant, so the relationship between centripetal force and the v is directly proportional with the square of the v. Okay, so therefore we can find the ratio of the new centripetal force. So label down that as F2. Okay, this is F2. So we are looking for ratio between V1 and V2. But it says here, given F2, when the same mass moves in same circular path with speed V2, the new centripetal force is half of that first. So means that the new centripetal force, which is F2, half means 1 by 2. Half of that first. Half of that, the first means the F1. So means F2 equal with F1 divided by 2. Right? So here we can find the ratio between F2 and F1. So using this relationship. Okay, so F2 divided by F1 is equal with V2 squared divided by V1 squared. So by using the relationship, force and the V is proportional. Okay, then we put in the value of F2 as F1 divided by 2 and F1 as F1. And the V2 by V1 test squared. And then simplify the F1 can be cancelled out, leaving just and a half. So half is V2 by V1 and taking out the square. And then you are looking for V2 by V1. So then we can bring away the square to the left side. So V2 by V1, make it a square root. So it makes a square root 1 by 2. And then you can press your calculators in. Therefore, the answer is 0.7. So number 4 is B. Okay, next we proceed to the subjective question. So number 1, with the help of a diagram, describe uniform circular motion. Right, so this is the same pictures we drew before for the question objective. So we can take a mass m of an object. So draw a circle. So this is the circle. And then to describe the uniform circular motion, you have to put V, which is tangent to the curve, and the AC is pointing towards the center. So it's not just only in one position, so you have to make minimum 2 positions around the circle. So at the second position, so V is now pointing downward because it moved in clockwise direction. And the AC is still pointing towards the center. Alright, so minimum for describing the uniform circular motion is in 2 positions. Okay, so minimum, so this is how the mark goes in a real exam. So minimum in 2 positions. So any positions along the circle. And then the mark goes if you label down the V and the AC in right angle triangle. Okay, let me do with some pen, that one. So the first mark is if you draw the V and AC, which is in right angle triangle, and you also shows the circle and in 2 positions of the object around the circle. So this is 2 marks for the exam. So next, question B. Define the centripetal acceleration. So you can use the formula to define the centripetal acceleration. So use it as Fc equal with mv squared divided by r, but we have to define each of the symbol used to get the mark. So which is m, mass, the v is the tangential velocity, and r is the radius. And then another mark goes if you describe the directions of the centripetal force, which is towards the center of the circle. Okay, next question B is centripetal acceleration and C is centripetal force. So this is answer C. Let's just change question. And for definition, centripetal acceleration, again, you can use the formula of AC, which is V squared divided by R. But to get the mark, you have to define each of the symbol used, which that V is the tangential velocity and R is the radius. And again, you have to shows the directions of AC, which is towards the center of the circle. Alright, so this is how you do the definition. This is just the basics of circular motion. Normally it's bring up to 1 or 2 marks only. Okay, next, question number 2. A gramophone rotates at 33 1/3 revolution per minute. So given omega, so omega is 33 1 RPM. Revolution per minute, this symbol can be short as RPM. R stands for revolution, P is the ratio, division per, M stands for minute. So here you can convert it to radian per second. So 33 1/3 is equal with 100 by 3 because you multiply 33 by 3 and then plus 1. So 33 plus 3, this one you have to multiply and then bring up is plus. So got 100 divided by 3. This is in revolution per minute. How to do it? Let me do it again. So 100 divided by 3 revolution per minute. So you have to convert to radian per second. So in the first bracket is conversion for 1 revolution equal with 2 pi radian, and the second bracket minute to second. So then minute and revolution can be cancelled out. So 100 by 3 divided by 2 pi times 2 pi divided by 60. So that is the omega. So it is 3.49 radian per second. So this is question A. Okay, next question B. The speed of a point on its circumference. So V is the speed, which is equal with R omega. Given the radius is 0.15, omega is 3.49. Press in the calculator. We got 0.52 meter per second. And question C is to find the centripetal acceleration. So centripetal acceleration is AC. The formula is AC equal with V squared divided by R. So you just substitute V as 0.52 squared divided by R, which is 0.15. And then you got the answer is 1.80. The unit is in meter per second square, just like the linear acceleration. And then to get the mark, you have to show the direction because this is a vector. If this is compulsory to write down as well in your exam. Highlight. So let me do remarks. Mami tidak. Be compulsory. So this is compulsory to mention the direction. Okay, the direction is towards the center. Okay, next question number 3. Okay, we're done. Number 2 done. Okay, next question number 3. Calculate the centripetal acceleration of an object at water. Just wait a second. Okay, better. So calculate the centripetal acceleration, AC. We are looking for AC. An object at the equator. So the concept you must know at the equator is the period is equal with 24 hours. So 24 hours is equal with 24 times 60 minutes times 60 seconds. So which is 86,400 seconds. So 24 hours is equal with 86,400 seconds. So this is the concept at the equator. This is the basic you must know. And then given the radius of the Earth is 6.37 exponent 6 meter. So to find AC, we can use the formula V squared divided by R, but we are given the period. So instead of using this formula, we can use another formula, which is R omega squared. So I'm going to show you how we got it, because V is R omega, and then you're taking square of it, divided by R. So there is R squared up and R down. So you can cancel up one R, leaving as only one R, and omega has square. So AC is R omega squared. So therefore you can just sub the values in. And the omega is given as 2 pi by period. So 2 pi by period is 86,400. Don't forget the square as well. So you got 3.37 exponent minus 2. The unit is in meter per second square and towards the center. Alright, so this is how you do question number 3. Okay, next, let's see question 4. An object of mass 0.2 kilogram on the end of a string is swung around in a horizontal circle. So this is horizontal circle. So given an object, so this is the object of mass m. So write down that as m, mass is 0.2 kilogram. The mass is on the end of a string. So then the swing is in a horizontal. The string is swing in a horizontal circle. So this is the string, so it must be tension present. Given as well, the radius of the circle is 0.8 meter. So then the radius is equal with the length of the string. because the string makes a circle. So from the center of the circle to the mass is the length or the radius of the circle. Then the v is given as well by 4 meter per second. So question is to find the tension in the string. So to find the tension in the string, you have to first draw the free body diagram. This is compulsory. So draw the free body diagram acting on the object. So the object draw as a point mass. So it has mass, so therefore it has weight pointing downward. This is the weight. And along the rope has tension. Okay, then the tension direction is away from the object. So means it goes to the right. So this is tension. And then also in the free body diagram, you have to label down the directions of AAC. So this is the locations of the object on the right side of the circle, and the center of the circle is on its right. So therefore, AC is towards the right. Okay, so this is directions of AC because this is object seeing the center in the right side of it. So AC is to the right. Okay, so we are looking for the tension. So the concept to be used here is the FC is equal to mv squared divided by r. Okay, this is formula for centripetal force. And then you have to think what is the FC. So FC in this case is the force parallel to the centripetal acceleration. So there's only tension force. So therefore, tension is the mv squared divided by r because the tension is the FC. Okay, so this is the concept 1 mark for concept mark. And then you just straight away put the values in. Mass 0.2, V is 4.0, then square it. R is 0.8. Therefore, we got the answer as 4 Newton. Next, for question 5. So question 5. What is the speed of an aircraft? Okay, this is involved a horizontal circle as well. So we draw the horizontal circle. So this is the aircraft. Nice aircraft. Given the radius of aircraft, so it means this is R. So R is 300 meters. If the acceleration experienced by the pilot is 4g, it means given the A experienced by the pilot is 4g. G stands for 9.81. So the acceleration feels by the pilot is 4 times 9.81, 39.24 meter per second square. Right, so we are looking for speed V. So what is V? So you can use the formula that the centripetal acceleration is equal with V squared divided by R. Okay, because the acceleration experienced by the pilot is actually the centripetal acceleration, which is towards the center. So this number is actually 39.24. And then you are looking for V squared, substitute R as 300, and then we got the V. So the answer is 108.9 meter per second. So this is the speed of the aircraft. Okay, next question number 6. So question 6, name the force that is responsible for the following motion. A is satellite orbiting the Earth. The answer is gravitational force. Okay, because this is orbit of satellite. So this is the satellite of mass m, and then it going round an Earth. So this is mass of Earth. So to find the force here is referring to the centripetal force. So you are looking for any forces which is in parallel to the AC. So in this case, the satellite goes in circle, so AC is towards the center of the Earth, and then only gravitational force acted on the satellite. The weight has no effect at all because it is in the space, so it's a weightless. So therefore, only gravitational force, because only gravitational force is parallel with the centripetal acceleration. So B, a ball attached to a string that swirls. Swirls means spin, the same vocab, spin, horizontally. So in this case, the answer is tension force. Okay, because again, horizontally means a horizontal circle. So you are having a ball, so attached to a string. So the string, one end in the center and the end is on the ball. So there is a weight going down, and then there's a tension, and the AC is to the right. So you can see that only tension force is parallel with the AC. So therefore, the answer is the tension force, not the weight. Okay, next, question 7. So for question 7, you are given an object of 2 kilogram mass. So given M, 2, is whirled in vertical circle. So this is a vertical circle. So you can draw the vertical circle. Just wait a second. So this is vertical circle. With a constant speed of 6 meters per second. So given as well, V, 6 meters per second. And the radius of the circle is 2.5. So radius is R, 2.5. Determine the centripetal force of the object. Okay, so let's draw this object M. So this is the center, labeled down as point O. Question A, centripetal force. So FC, we use the formula which is mv squared divided by R. Just substitute mass 2.0, V is 6, and then forget the square, R radius is 2.5. .8 Newton. And B, maximum and minimum tension of the string. So there's also a string here. So this is the string. So maximum tension occurs at the bottom of the circle. So this is the bottom of the circle, and this is the string. So the maximum tension occurs at the bottom of the circle. Okay, therefore at the bottom of the circle, you draw the free body diagram. Okay, at the bottom you have weight pointing down and the tension pointing up. Okay, so this is tension and this is weight. And then since it's at the bottom, you are seeing the center up above you, so means AC is upward. Okay, so you are looking for magnitude of tension, so you can use the formula of centripetal force, which is mv squared divided by R. Okay, so what is the FC? So this FC is the forces which in parallel with the AC. So you have tension and the weight which is parallel with the AC. So it's not just tension, it's not just the weight, but there are two forces which responsible for the centripetal force. Okay, so since AC is pointing upward, therefore the tension is minus with the weight. So tension with the weight equal with mv squared divided by r. Okay, then you can substitute the values in. M is 2, G is 9.1, and mv squared by r is just taking the answer for A, which is 28.8. So then we got tension force. For 48.42 Newton. Okay, next, minimum tension. So minimum tension will occur at the top of the circle. At the top of the circle. So this is the top of the circle. This is at the top of the circle. This is at the bottom of the circle. So you must know here is that the tension felt by the mass M will not be constant, will not be equal along the vertical circle. It feels more tension at the bottom and less tension at the top. So therefore, you have to draw the free body diagram at the top of the circle. So at the top of the circle, you have weight pointing down and also the tension away from the object also pointing down. So AC is downward as well because at the top you're seeing the center down below you. So AC is pointing down. So let's draw the free body diagram. At the top, you have weight and the tension. And the AC is also pointing downward. And again, you can apply the formula FC is mv squared divided by r. And now the FC is those forces which in the same direction. So you have to add up, okay? Because tension and the weight is the same direction. So add up tension with the weight. Okay, therefore, tension plus mass is 2 times 9.81 equal with mv squared divided by r is the answer A, which is 28.8. Therefore, the minimum tension is 9.18 Newton. Okay, so this is how you do question 7. And question 8. So question 8. Figure below shows a child riding on a Ferris wheel. So given the diameter of the Ferris wheel is 4.5 meter. So this is the diameter. The D diameter. So you can find radius from the diameter. It rotating at constant speed. So draw the free body diagram and write equations for forces acting on the passenger at position A and C. Position A is at the top of the wheel and the C is at the bottom of the wheel. So you have to come up with the equations of forces. Equations of forces, this force is actually the centripetal force because it's a circular motion. So means we are looking for centripetal forces. So you have to draw the free body diagram at A, which is at the top. So then the person is sitting on the chair. So means it has a normal force pointing upward and the mass has weight, so pointing downward. This is at the top. Let me go back to the picture. So this is the person sit on the seat. So means there's a normal force and it has weight pointing down. And since it's at the top, it's the person sees the center below her. So then the AC is pointing downward. Okay, therefore we can put out the centripetal force. which are normal and the weight, but the AC is pointing down, therefore the weight minus the normal force. Okay, this is the equation, the weight minus with the normal force. And at the bottom of the wheel at C, let me go back to the picture. So here the bottom part, it also has weight pointing down and the person still sitting on the chair. It doesn't tilting, it doesn't tilt downward. So the normal is still pointing upward. You cannot say that at the top, the normal going down just like the tension. No. If it happen, what happens is that the person will fall down because the seat is now at the top of her head and the head is at the below of the seat. So then the person will go down, will fall down. So that's not make sense at all. So normal force remain upward. Normal force remain upward at any position, A, B, C, or D. Okay? Normal force always upward at A, B, C, or D because of it wanted to remain seated. Because the person want to remain seated. Okay, you cannot say and is pointing downward at the top and the bottom is an upward. Wrong. Okay, next. We can draw the free body diagram. At C, normal is upward and the weight is downward, and now AC is upward. So we can take out the formula FC as now N minus with the mg. It differs from the top, mg minus N. At the bottom, N minus with mg. Right, so that's how you do question A. And question B, what is the maximum angular speed? Angular speed is omega. So that the passenger is not thrown out from the chair. So you are looking for omega. So how to find omega? The concept here, so that the person cannot be thrown out if the acceleration, which is centripetal acceleration, is constant, which is constant g, 9.81 meter per second square. Okay, so if the person feels the constant acceleration on her seat, so it won't thrown out from the chair when the wheel goes around the circle. So AC must be equal with 9.81. So then it won't be thrown out. So you have AC and then you are looking for omega. Therefore, you can use the formula AC, which is R omega squared. Okay, given the diameter from the question, the diameter is 4.5. So to find radius, just divide by 2. Okay, so R is 4.5 divided by 2, which is 2.25 meter. So R here is 2.25 omega squared, and AC is 9.81. So you can press in calculator, then find the omega. The answer is 2.09 radian per second. Okay, guys. Okay, this is the end for the part A question. So we're going to see again for part B to continue with the question 9 subjective question. Given a car travels at a constant speed of 13.4 meter per second. So you can write down the known quantity, which is V, 13.4 meter per second, on a level circular turn of radius 50 meter. So R is 50 meter. So as shown in the bird's eye view in the figure below. What minimum coefficient of static friction mu s? So we are looking for mu s between the tires and the roadway will allow the car to make the circular turn without sliding. So in this case, we can see the car not only from the bird's eye view, we can see it from the back of the car. So this is the back of the car and this is the tire. And here is the road. So you are viewing from the back. This is your eyes of view from the back of the car. And then what you see is that the center is on the left side. So it means this is the AC. So the car has mass, so it has weight. So weight is pointing down. And the tires, there are 4 tires. The average of the 4 tires touches the road, so means there's a normal force upward, and there is a friction force acting on the tire. So to know the directions of the friction force, you have to know that the car wanted to sliding, don't want to slide. Slide means sliding. What is the word in Malay? Sliding. What is that word? What is sliding means? Right, so sliding. Tergelongsor. Menggelongsor. Sliding. So it doesn't want to sliding. So you have to know the directions of friction by knowing the directions of motion of the car when it is sliding. So what happened is that when this car wanted to make the left turn, based on the picture here, you know that the car wanted to turn left. So the car wanted to turn left, but the body of the car will sliding to the right. Just like when you drive in a car at the back seat, imagine that you are sitting on the back. Okay, so imagine this is you. Okay, you are sitting on a seat. So this is at the back seat of the car. So when your daddy make a turn to the left, so this is motion of the car. Okay, the car turns to the left. What happened to your body? What happened between your body and the seat? So what do you feel? So you're gonna feel some forces goes to the right because you are the one that moving to the right. So if your daddy makes turn to the right, what happens is that your body will sliding to the left. So if your brother or younger brother is sitting next to you, what you normally do during when you were a kid, you normally like push your siblings. When your daddy's car turns left, and then you push your sibling to the right. And when your daddy make it right turn, you push your brother towards the left. So this is the motion. This is actually the motion of the car seat and your body. So this motion is to the right when the car turns left. So therefore, the friction is in directions of opposite to the motion. You know this concept before. You learned that in chapter 4, the directions of friction is opposite to motion. Okay, so therefore, it goes to the left because the motion is to the right. We are not refer the motion of the car. Even though the car turn left, that is not that motion that causes the friction because the friction presents between your body to the seat. So your body to the seat will make a motion to the right because the car turn left. So therefore, the friction is opposite to that motion. So F is to the left. Okay, just seem like the tires and the road. When the car makes turn to the left, the tire will sliding to the right because the motion of the tire, it tend to go to the right. This is motion. Therefore, there will be some friction opposed to the motion. So then it will remain in the circle. So therefore, the friction is to the left. Okay, this is the explanation of why that the friction is towards the center of the circle. So please remember, the friction is opposite to the motion, correct? But in chapter 6, direction of friction is always towards the center of the circle. So if the car moves to the right, means that the circle is on its right. Therefore, friction to the right. If the car moves to the left, means that the center of the circle is on the left. The friction is towards the left. Okay? Please remember that friction. So therefore, this is the free body diagram. Normal force is upward. Let me redraw the free body diagram. Normal force is upward. The weight is downward. The friction is to the left as the same direction to the AC because the center is on its left. Okay. Therefore, back to the question, it asks for coefficients of static friction. So you know the concept. The centripetal force is mv squared divided by r. So now Fc, centripetal force, is the friction force because only friction is parallel with the centripetal acceleration. So therefore, Fc is equal with friction. And since the friction is mu n, so Fc is mu n. N is normal force, equal with mv squared divided by r. And then you know that the n is along y-axis. So n is equal with the weight. Okay, because in opposite direction, same magnitude. So n is equal with the weight. So you can put that n here as the weight, mg, equal with mv squared divided by r. So you see that on the left and the right side, there is mass that can be cancelled out. So you can find the mu. Mu times g, which is 9.81, equal with v squared divided by r. 13.4 squared divided by 50. So we can calculate the mu. Which is 0.366. Remember, coefficient has no SI unit, so just leave it as it is without unit. Okay, next we proceed to the question 10. So question 10. A student is to swing a bucket of water in a vertical circle. So let's draw the vertical circle without spilling any water. Okay, so it's just like you are holding a bucket. So this is the bucket of water. Inside there's some water, and then you hold it on the handle. This is your hand, something like this, and then you make it vertically up along the circle. So at the top, the water is above, and this is still your hand holding it. This is your hand. It says the distance from his shoulder to the center of mass of the bucket. So this is the center of the mass to the center of the circle. That is actually the radius. So given r is actually the radius. So radius from this case is the distance from the shoulder to the bucket of water. Okay, so that is actually the radius. What is the minimum speed required to keep the water from coming out? Means that the water want to remain inside the bucket. So we are looking for V. So the concept here is that to make the water from coming out at the top of the swing, the water must have constant acceleration, which is centripetal acceleration, which is equal with G, which is 9.81 meter per second square. Because the problem here is on the Earth, so the value of centripetal acceleration must be equal with the value of the gravitational constant of the Earth, which is 9.81 meter per second square. So to find the V for the question, you can use the formula of centripetal acceleration. So in this case, at the top of the swing, AC is pointing downward. So AC is V squared divided by R. So AC now is equal with the value 9.81. And the V is the one we are looking, R is the radius. This question number 10 is similar with the questions from the Ferris wheel. The Ferris wheel question, the person wanted to remain on its seat because the constant acceleration must be both equal with the gravitational acceleration of Earth, 9.81. Okay, then you can take a square of 9.81. And you got the answer as 3.13 meter per second. Okay, so this is the answer 10. Okay, next we move on to question 11. Question 11. A ball of mass m, so this is ball, mass m, move with constant velocity. So the case with the horizontal circle. So this horizontal circle has radius r. So this is r. The ball is attached to a string of length L 24 centimeters. So this is the length from the ball to the wall, to the ceiling. Sorry, not wall, ceiling. This is ceiling. So L is 24 cm, 0.24 meter per meter, and makes a conical pendulum as shown. So sketch a free body diagram showing the forces acting on the object. So the object referred to the ball. So the ball has mass, therefore it has weight pointing down, and attached is the string, therefore it has tension away from the object. So this is tension. What are there another force acting on the ball? So no, there are only two forces, tension and the weight. And you must label down the AC, centripetal acceleration. So to show directions of AC, you have to find the circle. So the circle is in the horizontal. So means that AC is either to the left or to the right. But since the center is on the left of the ball, so therefore it's AC to the left, not to the right. Okay, so we can draw it in a proper free body diagram for question A. So the ball mass, just draw as a point mass, draw the weight and the tension. Okay, then do the axis in the dot line, and don't forget label the AC towards the center. And there's an angle theta. Okay, theta is from y-axis to the tension. Okay, this is y-axis and this is tension. So this is theta. So this is the one mark for free body diagram. Okay, next question B. So given theta is 30 degrees, calculate the radius. We are looking for r, radius, this r, and the velocity of the ball mass when you move in the circle. So to find r, we must notice that the relationship between r L and theta is in a right angle triangle. So we can redraw the right angle triangle. So this is the right angle triangle. The base is R. This angle is theta, this one. And this hypotenuse is the length, which is 0.24. Therefore, you can find that relationship between theta, R, and L is given by sine theta. Because sine is opposite divided by hypotenuse. So opposite is R, hypotenuse is L. So therefore, R is L sine theta. That's how you find the question radius. So R is L sine theta from the right angle triangle. So L is given by 0.24 and theta is 30 degrees. So the answer is 0.12 meter. So that is how you find radius. Okay, next, question 2. To find the velocity. Okay, so to find the velocity, you must know that the velocity presents for x-axis. So you can use concept for x-axis. So this is free body diagram. So AC is on the x-axis. So means the concept along x-axis is SC equal with mv squared divided by r. Because AC is v squared divided by r. So since AC is v squared divided by r, so FC is MAC. So MAC is just the same with mv squared divided by r. So this is concept for x-axis. Okay, and then we can think of forces that is parallel with the AC along x-axis. So weight is having no x-axis, no x component, but the tension has its own x component. So this is T, this is theta. So the components of tension is T sine theta. So the tension sine theta is pointing to the left. Okay, so since it's pointing to the left, it is parallel with the centripetal acceleration. So therefore, the FC is the T sine theta. Okay, so T sine theta equal with mv squared divided by r. Okay, so you may leave this because you are looking for V. There is no given for mass. Mass is not given. Tension is not given. R, we knew it. So there are lots of unknowns. So just leave it as the first equation. And then we can solve for y-axis. Okay, on the y-axis, this is y-axis. We can use concept that the net force is 0 because the ball is not moving along y-axis. It only moves along x-axis in a horizontal circle. So horizontal means x-axis. So the concept for y-axis is net force equal with 0. So then we can see there are two forces along y-axis. One is the weight and the second is the T cos theta. T cos theta is pointing upward. Okay, so write down that T cos theta is the weight. Then leave it as the second equation. So here you can use a bit of math trick. Okay, you are having two equations. In order to find V and cancel out the unknown, the way to do this is by dividing those equations. So see the magic happen. If you divide T sine theta by T cos theta, you can just cancel the tension without looking for it. And the right side is mv squared divided by r and then divide by the mass times g. And again, without finding the value for mass m, you can just cancel out mass, cancel out tension. And here you have to know that the sine theta divided by cos theta is Math's formula, which is equal with tan. So tan is sine by cos. Remember that. Tan is sine by cos. Okay, so simplify sine theta by cos theta is the same with the tan theta. And on the right side, you are living with V square divided by R and G put together, RG. Okay, then you can find the V because R, G, and theta is known from the question. Theta is 30 degree. R is 0.12 from answer A, and G is 9.81. And then you can find V. Is this hard for you? I hope not. It might be harder if on the first time. On the first time you are doing this question, you might find it hard. On the second time, third time, fourth time, fifth time, sixth time, you'll find it, oh, easy peasy lah, senang saja. This is the velocity from the question. Alright guys, so we move on. Question 12. Okay, so question 12. A model airplane. Okay, this is airplane. The mass is given, M. So the mass is 0.75 kilogram with a speed. So V is given, 35 meter per second. In a horizontal circle at the end of 60 meter control wire. So there must be tension present because attached to the airplane is a wire. So wire create tension. 60 meter. So the wire length is 60 meter. This is not the radius, no. The radius is not along the wire because it says here, read the next sentence is the force exerted on the airplane is shown and the tension in the wire is in 20 degree inward from the vertical. So means that the radius is not along the wire. So what does this mean? That you can draw the relationship between the length, angle theta, and the radius. Okay, so if you complete the shape of this circle like this, so you can see that this airplane is attached to the string. So this is you. You are holding this string or wire. You're holding it and then move it in a horizontal, just like a cowboy. Just like the cowboy. Cowboy ke? Cowboy that wanted to baling tali, apa tah nama dia, cowboy. So then the radius of the circle is not along the wire. So this is center. So this is the radius R. And the length L is the length of wire. Okay, this is the vertical position, makes angle theta, makes angle 90 degrees. And the 20 degree here is referred to the angle from the wire to the horizontal axis. So this is 20 degree. Okay, so hope that it clears you out. 60 meter is not the radius. So 60 meter is the length. Okay, so L here is given. So if I wanted to draw it in a clearer picture, I can draw it in a right angle triangle to find the radius. Okay, this is 20 degree. So this is radius and this is L, which is 60 meter. So in this case, it is not to use sine theta or sine 20 because we doesn't know the opposite to the angle 20. We knew the adjacent, which is R. We knew L, which is the hypotenuse. So it's preferred to use cos in this case. So cos 20 is adjacent divided by hypotenuse, which is R divided by L. So therefore we can find the R, which is L cos 20. L is 60 times cos 20. 56.38 meters. So this is the radius of the circle. And then we are looking for what the question actually asked. I forgot. We are actually finding the tension force in the wire, which is T. So we can draw the free body diagram. So the plane has weight pointing down. Okay, it already simplified the free body diagram. It has tension. The tension is along the wire, tension. Okay, and then label the angle theta. Okay, and then from this situation, you have the third force, which is the uplift force. Uplift force is normally the air friction force. The air friction force is the force responsible to allow the airplane to floating in the air. Okay, so then from the situation, the direction is given as well. So this is the F lift. F lift is normally is the air resistance force. Since F just draw as F. And given as well angle theta, which is also 20 degree. Okay, good. So in here, you can use the concept that x-axis has centripetal acceleration. So this is the directions of AC because the circle is in horizontal. The circle is in horizontal, so from the A plane is either left or right. So the answer is to the left because the center is on the left. It's not AC along the tension. No, it's not AC along the F lift. No, AC is to the left. So we can compute that X component. The concept is Fc equal to mv squared divided by R. So you have to come up with the forces responsible for the centripetal force. In this case, you have to look for the forces in parallel with AC. So the forces parallel with AC are two forces. The first is the T cos theta. So this is T on the third quadrant. So it has X component, which is this one. This is theta, so this is T cos theta. Okay, and the second force that is parallel with AC is the component of Fx. So F is on the second quadrant, so it has Fx, which is to the left. So this Fx is F sine theta. And the weight has no X component. So means the forces that are responsible for the centripetal force are T cos theta and F sine theta. Since they are in the same direction, you have to add them up. Okay, so T cos theta plus F sine theta. These are Fc. And then equal with mv squared divided by R. And then you can put all the values in. We know the F. Do we know the F? No, we don't. So just leave it as F. The mass is 0.75. Do we know the V from the question? Yes, 35. So we already find the R, which is 56.38, and then simplify it. So cos 20 is 0.94 T. Sin 20, 0.34 plus 0.34 F. And on the right side, you simplify it. So you got 16.30. So there are two unknown, tension and force, uplift force. We are looking for tension. We don't want the F, so make it as the first equation. And this is X component. Then we solve for Y component. So the concept for Y component is not Fc, it's mv squared by R. No, because there is no centripetal acceleration along y-axis. If one axis have component Fc if is mv squared by r, another one must be net force equal with 0. It always be like that. It's either one is MAC, another one must be 0. So net force is 0 on y component. And then on the y component, we can see there are 3 forces. So there are 3 forces along y component. So the first force is the component of Fy. Okay, the component of Fy is pointing upward. So this is F cos theta. Upward. The second force is the component of tension, okay, which is pointing downward. Okay, so T sine theta, pointing downward. Okay, and then the third force is the weight, which is pointing downward. So there must be 3 forces. 2 forces downward, another force upward. Therefore, F cos theta is T sine theta plus mg. Why? Because opposite forces is equal in magnitude. So upward force is equal with downward force. So you have to add up the downward forces. T sine theta and mg are downward forces. And then you can put the values in. And simplify. Cos 20 is 0.94. This is F. Sine 20 is 0.34 plus 7.36. Okay, since you are looking for tension, you can make force as the subject. So you can simplify, bring down the 0.94, and then each of 0.34 and 7.36 divided by 0.94. So 0.34 divided by 0.94 is 0.36 tension plus 7.36 divided by 0.94. This is my way on simplify the expression. So you got 7.83. So therefore, since you got 2 expressions, so you can equate, substitute 2 into expression 1. So from expression 1 is 0.94 tension plus 0.34. F here is now 0.36 tension plus 7.83 and equal with 16.30. So this is a bit long solution, so you have to be extra careful when calculating it. I sometimes make some mistake as well. It's okay to make mistakes. Better learn from mistakes than it doesn't learn at all. So here you got 0.1224 tension plus 2.66 equal with 16.30. So simplify this tension. So I equate 0.94 plus 0.1224 equal with 1.06 tension, and 2.66 I bring it to the right. So 16 minus 16.3 minus 2.66, 13.64. Therefore, tension 12.86 unit is Newton. So this is how we look for tension force.